Today we're going to talk about numbers and what exactly is a number. And when we think of numbers, we think 1 through 10, 20, 30, and we have to expand our mentality of thinking about numbers. But let's go back and discuss a little bit why we work in what's called a decimal system. We work in a base 10 system. Well, for example, if you look here, I got 10 toes, 5 on each foot. And when you look at fingers, see, I got 5 digits on each hand, and I got 2 hands. So everything about the human existence is based on the number 10. 10 digits on your feet and 10 digits on your hands. So over time, we always think of things on a basis of number 10. But that's really a numbering system. So let's go back to the original question. What is a number? A number is a representation of a value using particular digits in a specific sequence. Let me zoom out just a fuzz on that. A number is a representation of a value using particular digits in a specific sequence. Now you're going, what did he just say? A number's not a number? No, a number, like the number 11, is a representation of a value using particular digits in a specific sequence. So if my number is 11, then my particular digits are 1 and 1 in a specific sequence. And it becomes important to understand that concept of what a number is. So a number is a representation of a value. And when we see 11, we think of 11, because 11 is the value. One number, so the representation 11, for example, can represent infinite values as there are infinite numbering systems. So let's comprehend that for a second. Let's get our mind around that. There's infinite numbering systems because there's infinite bases to numbering systems. And so since there's infinite bases, we can have a base infinity numbering system. Then each number can represent an infinite number of values. Now in the engineering world, the 3 most common numbering systems are the binary system, and that's a base 2 system. The decimal system, that's the base 10 system. That's what we're used to because we have 10 digits on our feet and 10 digits on our hands. And a hexadecimal system, which is a base 16 system. So let's give you an example here. So we're going to look at the values of 1, right? Now we think that's 11, but this is a number. So the number is 11. That's how that's read. So in the base 10 system, the number 11 is 11. That's how we would read that. And then, of course, I put B10 to show that I'm talking base 10. In the base 2 system, 11 is the same as the value of 3 in the base 10 system. And in the base 16 system, 11 has a value of 17 in the base 10 system. And I'm just going to throw this out here that since common mathematics, since the mathematics that we're all used to, and again, it goes back to the very beginning when we started counting fingers and toes, is base 10. We're going to assume that all values that are returned are base 10 values. So when we speak of the word value, automatically assume base 10. And that will make it a little bit easier to understand. So 11 base 2 has a value of 11, has a value of 3. 11 base 10 has a value of 11, and 1 base 16 has a value of 17. So what I've done is I've created this table, and since those are the three common systems, I've created this table from a value of 1 through a value of 16, showing all the different numbers in these three common systems. The top row here is base 2, this is the base 10, and this is base 16. So, for example, a value of 5 in base 2 is 101. A value of 5 in base 10 is 5, and a value of 5 in base 16 is also 5. So we'll go up here to 9, for example. In base 2, the value of 9 is the number 1001. It's not 1001, that's a value. It's the number 1001. And that's how we need to get in the habit of when we read numbers, that's how we read numbers out. We read each digit in a sequence. So the number base 2, 1001. So it's the digit 1, the digit 0, the digit 0, and the digit 1. 1001 has a value of 9. Now here's where it gets kind of interesting, is when we get to the value of 10. So value of 10 in base 2 is 1010. In base 10, it would be 10. In base 16, it's A. Because remember, base 16 is a numbering system where you have 16 possible digits. So you have 0 through 9, and then you have 6 more. And they're used A, B, C, D, E, F. So let's go up here to 13, for example. In base 2, the number base 2, which gives the value of 13, is 1101. The number base 10, which gives the value 13, is 13. The number base 16, which gives the value 13, is D. And let's go over here all the way to the end at the value 16. So the number base 2, which gives the value 16, is 1, 0, 0, 0, 0. Or as we would look at it, it looks like 10,000, but again, that's a value, not a number. So it's the number that looks like 10,000, but it's 1, 0, 0, 0, 0, base 2, is the same as a value of 16. In base 10, the number that gives the value of 16 is 1, 6. In base 16, the number that gives the value of 16 is 1, 0, because we've used up the first 16 digits in that first part of the sequence, and now we're into the second part. Each place in a number represents an exponential power. The first place in a number, that's the place all the way over to the right, is the 0th power. The second from the right is the first power. The third from the right is the second power, and so on and so on. So the number 111 is, that first digit is b to the 0th power. The second digit is b to the first power. And this third digit is b to the second power. And b is the base of the numbering system you're using. So for example, for base 2, the number 111. This represents 2 to the 0th power. This represents 2 to the first power, and this represents 2 to the second power. So I have 1 that's at 2 to the 0th, 1 at 2 to the first, and 1 at 2 to the second. So what's this going to be? 2 to the second is 4, so I have 1 in the 4, 1 in the 2s, and 1 in the 0s, the single digits, because 2 to the 0 is 1. For our base 10 system, for example, the number 111, 10 to the 0th, 10 to the first, which is tens, 10 to the second, which is hundreds. So we can read that as 100, because that's 10 squared, 1, 10, and 1, 1. So again, up here we have 1, 4, 1, 2, and 1, 1. So this 1, 1, 1, obviously 1, 4 is 4. 1, 2 is 2, and 1, 1 is 1. So that's the equivalent value of 7. So here, our equivalent value is 111. For base 16, for example, this one is 16 squared. That one is 16 to the first. And this one is 16 to the 0th. So to determine the value of a number, remember when we say value, we're talking what we assume base 10. So the value of a digit times base to the I, so this is going from left to right. So the far left one is the value of the digit times base, whatever your base is, to the ith power, plus value of the digit times whatever your base is to the ith minus 1 power. So let's assume that the ith power here is 5. So it's going to be the value digit times whatever it is to the 5th. This is going to be value digit times whatever it is to the 4th. This next one is value of the digit times whatever your base is to the ith minus 2 power. So if this is 5, this is going to be 3, and on and on and on, with the final addition being the value of digit times base 0. So that's just going to be times 1. So it's just going to be the value of the digit itself. So let's do an example here. We're going to determine the value of 111 for base 2, base 10, and base 16. So 111 base 2, as we showed before, is 1. Remember, this first digit is going to be 2 to the squared, 2 to the first, and 2 to the 0th. So it's 1 times 2 squared for this first place. The second place is 1 times 2 to the first, and the third place is 1 times 2 to the 0th. So this is 4 plus 2 plus 7. Plus 1, which is a total of 7. So 111 base 2 has a value of 7. 111 base 10 here, we got 1 times 10 squared, so that's 100, plus 1 times 10 to the first, which is 10, plus 1 times 10 to the 0th, which is 1. So it's 100 plus 10 plus 1. And 111 base 10 gives a value of 111. And finally, for base 16, it's 1 times 16 squared, plus 1 times 16 to the first, plus 1 times 16 to the 0th. So 1 times 16 squared is 256. 16 to the first is 16, plus 16 plus 1. So 111 base 16 has a value of 273. To convert from a base 10 to other base number systems, start by dividing by the highest power of the base you want to convert into and still yield a value greater than 1. It sounds complicated, but it's really quite simple. So here's a quick example. We're going to convert the value 31 into base 2 and base 16. And since it's 31, we're not going to do base 10 because we're already talking base 10 anyway. So base 2, we want the highest exponential of 2 that goes wholly into 31. And that's going to be 2 to the 4th, or 16. So your first step is 31 divided by 16 gives me 1. So I know I have 1 that's in that place with a remainder of 15. So then we're going to repeat that for the remainder. So the highest exponential of 2 that wholly goes into the remainder is 2 to the 3rd, or 8. So on that second place, we have 15 divided by 8 is 1. So we're going to have 1 in that second place with a remainder of 7. Highest exponential of 2 that wholly goes into the remainder is 2 squared, or 4. So that's 7 divided by 4 equals 1 with a remainder of 3. And we repeat this thing again for the next one. 3 divided by 2 equals 1 with a remainder of 1. And then you want to read this backwards. So we had 1, that's this one, at 2 to the 0th. 1, which is right here, at 2 to the first. 1 at 2 squared. 1 at 2 to the third, 1 at 2 to the 4th. So 31 becomes 11111 base 2.